Ladies and gentlemen, welcome to the Manned Spacecraft Center. This is the Apollo 11 press conference. The format today will consist of a 45-minute presentation by the Apollo 11 crew, followed by question and answers. At this time, I'd like to introduce the Apollo 11 crew, astronauts Neil Armstrong, Michael Collins, Edwin Aldrin. Neil?
It was our pleasure to have participated in one great adventure. It's an adventure that took place not just in the month of July, but rather one that took place in the last decade. We all here and the people listening in today had the opportunity to share that adventure over its developing and unfolding in the past months and years. It's our privilege today to share with you some of the details of that final month of July that was certainly the highlight for the three of us of that decade. We're going to divert a little bit from the format of past press conferences and talk about the things that interested us most, in particular the things that occurred on and about the moon. We will use a number of films and slides which most of you have already seen, and with the intent of pointing out some of the things that we observed on the spot which may not be obvious to those of you who are looking at them here from the surface of Earth. The flight, as you know, started promptly. And I think that was characteristic of all the events of the flight. The Saturn gave us one magnificent ride, both into Earth orbit and on a trajectory to the moon. Our memory of that actually differs little from the reports that you have all heard from those previous Saturn V flights, and the previous flights served us well in preparation for this flight in the boost as well as the subsequent phases. We would like to skip directly to the translunar coast phase and undockings, the transposition and docking sequence.
This was our first look at the magnificent machinery which had been behind us up until this point, the booster. Of course, the first and second stages had long since separated, but this shows the LEM nestled inside the third stage, the S4B, after the translunar inject burn. This maneuver was an interesting combination of manual and automated techniques in that we programmed the onboard computer to make the turnaround, and then these final maneuvers were made completely manually. As I approached the LEM, I had an easy time because I had a docking target, which is not too clearly visible here, which allowed me to align the probe and the drogue, which is the dark spot you see on the upper right. During this time, I also checked out the proper vehicle response to my stick inputs, and here shortly you'll see the actual docking somewhat speeded up. There's the point of contact. And in just a second, you'll see a second, right there, a second small indication of the retract cycle when the 12
For the lunar module, of course, is in a sense upside down relative to the command module.
This is in lunar orbit, showing the separation of the lunar module from the command module as viewed through my window. This was a busy time for me in that I was taking these motion pictures through the right-hand window. At the same time, I was taking still photos through the left-hand window, and also flying my vehicle and probably poorly, and taking a close look at the limb as he turned around. My most important job here was to make sure that all his landing gear were down and properly locked prior to his gives you a better idea of the detail available with the 70 millimeter. Of course, this is a still, and shows the limb either right side up or upside down. I'm not sure which. It looks more like, to me, it looks more like a praying mantis than it does a first-class flying machine in this view, but it was a beautiful piece of machinery. The landing gear are at the top, and you can see the probes which indicate lunar contact as thin wires extending upward from the landing gear.
Of course, before we could undock, as is shown in this picture, we had to complete the activation. Now, the day before we undocked, we entered the LEM and went through an entire switch configuration check, and we exercised the various communication modes. In retrospect, since we did have a little bit of communication problems on the following day during powered descent, we would recommend that we might make a more thorough check of this on the day before descent. On the day that we did finally enter the LEM for the landing maneuver, we went through a staggered sequence of suiting, and we found that with all the simulations that we had run back here in Houston, or with Houston tied with our simulations in the Cape, that we were quite confident that we would be able to complete this LEM activation in the given time period, which was approximately 4 hours. We managed to get 30 minutes ahead of the time, and it allowed us to get a more accurate platform alignment check at one point. After the undocking maneuver, we went through a brief radar check, and then the command module executed a 2 foot per second maneuver away from us so that we would both be able to independently exercise our guidance system through a star alignment check, which we did following this separation maneuver. Now, this occurred in a vicinity close to the landing site, and you can see at this point the command module is traveling right over the center of our targeted point. He's approaching now what we call the cat's paw. Following this separation maneuver on the backside of the moon, we made a descent orbit insertion, which is a slightly over 70 foot per second maneuver that lowers our altitude down to 50,000 feet. We had 2 guidance systems working for us, and they behaved perfectly. Both of them agreed extremely closely as to the results of this maneuver. Following this, we used the radar to confirm the actual departure rate from the command module.
This is a view of the descent trajectory area as viewed through the LEM window during our activation. In the bottom right of the photograph is the crater Maskelyne, and in the bottom center is the final phases of the descent. The landing area itself is in the smooth area at the top of the picture, just before we arrive at the shadow, or what's called the terminator. We had seen a number of pictures from Apollos 8 and 10, which gave us an excellent understanding of the ground track over which we would pass during the descent. We're now looking out the right-hand window of the crater, and there's Maskelyne W. It occurred approximately 2 to 3 seconds late and degraded our ability to determine not only our altitude and altitude rate in the final phases, but also, and probably more importantly, our translational velocities over the ground. It's quite important not to stub your toe during the final phases of touchdown. And once settled on the surface, the dust cleared immediately, and we had an excellent foot. And of course, the surface was very fine-grained. We could tell that from our view out the window, but there were a surprisingly large number of rocks of all sizes.
This is the view out the right window. Up close to the horizon, you see a boulder field that was probably deposited by some of the impacts in the craters that were behind us. You see, most of the craters have rounded edges. However, there is a variation in the age of these, as we can tell by the sharpness of the edge of the crater. The immediate foreground area we'll see more pictures of later. It was relatively flat terrain, in contrast to looking forward along where the shadow of the lem is cast on the surface, and we see a zero-phase glow around the upper portion of the lem. The general color of the terrain looking down sun was a very light tannish color. This blended as we looked more across sun to a more sharper, well-defined features and more of a gray color. During the initial time period after touchdown, we went through various sequences to prepare us for immediate abort or liftoff if we found that that was necessary. We had found we had to vent the fuel and oxidizer manifolds a good bit earlier than we had thought. We went through these various checks and prepared for one liftoff that would occur about 21 minutes after the beginning of powered descent. The ground gave us a stay during this period. We did not have to make use of that. We then proceeded at that point into our simulated countdown, which consisted of checking our guidance systems. We made use of a gravity align feature where the inertial platform of the primary guidance would use the gravity vector to determine the local vertical. We would then compare this with the alignments that we had previously. We also made use of the stars through the telescope and aligning a crosshair by rotating the field of view until the crosshair superimposed on the star. This would give us the angular measurement of the star within the field of view of the telescope. We then determine the distance out by aligning another reticle spiral on this. We went through an averaging technique on board and then fed this information into the computer, and this came up with our various alignment checks. This was all in preparation for a possible liftoff that would occur about 2 hours after touchdown as Mike and Columbia came over for the first revolution. The ground network gave us a stay, and we continued briefly through the remainder of this checklist in our simulated countdown. And at this point, we terminated and powered down many systems on board the spacecraft and went into an eat period.
A number of experts had, prior to the flight, predicted that a good bit of difficulty might be encountered by people attempting to work on this. This didn't prove to be the case, and after landing, we felt very comfortable in the lunar gravity. It was, in fact, in our view, preferable both to weightlessness and the Earth's gravity. This led us to believe, this in conjunction with the fact that all the systems in the limb were operating magnificently and we had very few problems, to go ahead with the surface work immediately. We predicted that we might be ready to leave the limb by 8 o'clock, but those of you who followed on the ground recognize we missed our estimate by a good deal. This was due to a number of factors. One, we had house cleaning to perform, food packages, flight plans, and all the items that we had used in the previous descent to be stowed out of the way and prior to depressurizing the lunar module. It took longer to depressurize the lunar module than we had anticipated, and it also took longer to get the cooling units in our backpacks operating than we had expected. In sum and substance, it took us approximately an hour longer to get ready than we had predicted. When we actually descended the ladder, it was found to be very much like the lunar gravity simulations we had performed here on Earth. And no difficulty was encountered in descending the ladder. The last step was about 3.5 feet from the surface, and we're somewhat concerned that we might have difficulty in re-entering the limb at the end of our activity period, so we practiced that before doing the exercise of bringing the camera down, which took the subsequent surface pictures. Here you see the camera being lowered on what might be called a Brooklyn clothesline. I was operating quite carefully here because immediately to my right and off the picture was a 6-foot deep crater, and I was somewhat concerned about losing my balance on the steep slopes. The other item of interest in the very early stages of EVA, should it have been cut short for some unknown reason, was the job of bringing back a sample of the lunar rocks, and these photographs show the collection of that initial sample into a small bag, and then that bag being deposited in my pocket. This was the first of a number of times when we found two men were a great help. I quickly put up the TV camera. And then, more leisurely, but Buzz and I joined together to erect the American flag. We found on a number of occasions that we were able to help each other in many ways on the surface. You probably recall the times that I got my foot caught in the television cable and Buzz was able to help me extract it without falling down.
We had some difficulty at first getting the pole of the flag to remain into the surface. In penetrating the surface, we found that most objects would go down about 5, maybe 6 inches, and then it would meet with a gradual resistance. At the same time, there was not much of a supporting force on either side, so we had to lean the flag back slightly in order for it to maintain this position. So many people have done so much to give us this opportunity to place this American flag on the surface. To me, it was one of the prouder moments of my life to be able to stand there and quickly salute the flag.
The rest of the activity seemed to go very rushed. There were a lot of things to do, and we had a hard time getting them finished.
We did find that mobility on the surface was, in general, a good bit better than perhaps we had anticipated it. There was a slight tendency to be more nearly toward the rear of a neutral stable position. Balance seemed to be quite easy to identify, and as one would lean a slight bit to one side or the other, it was very easy to identify when this loss of balance was approaching. In maneuvering around, as you saw, this was one of my tasks fairly early in the EVA. I found that a standard loping technique of 1 foot in front of the other worked out quite well, as we would have expected. One could also jump in more of a kangaroo fashion, 2 feet at a time. This seemed to work.
There's too many interesting things to do. The surface, as we said, was fine-grained with lots of rocks in it. It took footprints very well, and the footprints stayed in place. The LEM was in good shape and exhibited no damage from the landing or the descent. It's a picture of the ladder with the well-known plaque on the primary strut. There was a question as to whether the LEM would sink in up to its knees. It didn't, as you can see. The foot pad sunk in perhaps an inch or two, and the probe in this picture was folded over and sticks up through the sand in the bottom right-hand corner, showing that we were indeed traveling slightly sideways at touchdown. There were a wide variety of surfaces. Here Buzz is standing in a small crater, and it gives a very good picture of the rounded rims of the what we believe are very old features.
The 2 experiments that you saw in a previous picture were deployed in a scientific equipment bay. We found that getting them down produced no significant problems, and here you see a view of my carrying these 2 experiments out to the deployment site about 70 feet to the south of the lunar module. You have a very good view of the varying depths of this upper surface layer. You see that along the crater rim, the small crater rim off to my left, along this the upper surface appears to be about 2 to 3 inches, and the subsurface has a slope that is rather ill-defined, and one has to be very careful in threading your way around these very small craters. Any long excursions, I feel, would take a good bit of attention as you're moving along to avoid walking along or down the slope of some of these smaller craters. This is the passive seismic experiment that was deployed and has been giving us good returns on the interactions of the moon. We had a little difficulty deploying one of the panels. I had to move around to the far side and release a restraining lever, and then the second panel came out. We had a little bit of difficulty determining, as Neil said, the exact local horizontal. And I think this is due to the decrease in the cues that a person has as to which way up really is. One has to lean a little bit more off to the side before you get this body cue that you're approaching off balance. And of course the terrain varied considerably in this area. This second experiment is the laser reflector. We've been successful in bouncing laser beams off this. It consists of 100 arrays of corner reflectors. The other experiment